In this question, the three statements are given for the molecular formula. Option A represents the definition of the molecular formula, so it is correct. In option B, the relationship between the molecular formula and empirical formula is explained, so that is also the correct. Whereas in option C, it is about the formula presentation to find a percentage of any element from the molecular formula. So, in nutshell, all the three options are correct. That's why the correct answer is option D. Next question, that is about to find the weight of one molecule of a compound. Now it is very important that to find the weight of one molecule of the compound. So if you find the molar mass for the given formula, it is 842 gram per mole. That means 1 mole of this particular compound shows 842 gram of the mass. 1 mole, that means Avogadro number of the molecules. So we can write Avogadro number of molecules is equal to 842 gram. Therefore, the mass of one molecule equal to molar mass divided by Avogadro number. In that way, the correct answer is option D. Now, in this question, the number of molecules are found in terms of Avogadro number. That means the Avogadro number is not multiplied with the rest part of the answer. Let me explain you what I mean this. First, find it out the mole. So given mass is 18 milligram. That's why convert them into the gram. 18 into 10 to the minus 3 divided by 18. So the mole is equal to 10 to the minus 3. And as we discussed earlier, the final answer has to be expressed in terms of Avogadro, so that don't put the value of Avogadro. Instead of that, let it be as a symbolic. So finally the answer is 10 to the minus 3 multiplied by Avogadro, and correct answer is option A. In these questions, we have to find the percentage of carbon in the carbon dioxide. As we are aware, the formula of carbon dioxide is CO2. So based on the formula, the percentage of carbon is equal to the 12 divided by 44 into 100, since the molar mass of CO2 is 44. Final answer is 27.27 percentage. That is option B. This is the question based on the limiting reactant and the excess reactant concept. Now, the equation is given. So based on that equations, first we calculate the proportion of nitrogen and the hydrogen in gram. 1 mole nitrogen reacted with 3 moles of hydrogen, that is 28 gram of the nitrogen reacted with 6 gram of the hydrogen. So in that way, as per the balanced equation, we can say in option A, the 56 gram nitrogen required 12 gram hydrogen. Why? It's very clear from that stoichiometry. 28 gram demands 6 gram. Therefore, 56 gram demands the double of 6, that is 12 gram. But in the option, it is given 56 gram nitrogen with the 10 gram of hydrogen. Whereas in option B, 35 gram demands 7.5 gram of hydrogen, and the given is 35 gram nitrogen with 8 gram of hydrogen. Then option C, that 14 gram nitrogen required 3 gram, but in option C it is given 4 gram. And option D, 28 gram required 6 gram, that is as per the option given. So overall, only in the option A, the proportion of hydrogen is less than that of the requirement. That's why it is called a limiting reactant. And in that way, the option A is your answer. Next is about the mole fraction. So here in that case, 1 molar aqueous solution is given. 1 molar aqueous means 1 mole dissolved into 1 kilogram of water. So you get the moles of solute, and the moles of solvent is 1 kg. That's why when you place all the mole value, you get The moles of solvent is 55.55. 1 kg of water means it is equal to 1000 gram, and 1000 by 18, that is equal to 55.55. So finally we get the mole fraction 0.0177, that is option A. The important in this question is about the decode of 1 molar terms. The next question is about the half-filled and fully filled configurations. Since we have a both in the question 3D5 and the 3D10, so definitely the half-filled and completely filled always produces the exchange energy, because in these both type of configurations electrons have the parallel spin, so they have a tendency to change their position, and due to that they releases some amount of energy which is called exchange energy. That energy released due to exchange of the position, and in this way the correct is option C. Because of the exchange energy, the stability of the molecule or the atom get increased. Now, in these questions, the electrons are expressed into the different shells. So, based on that, first shell having only one orbital, we have expressed it as a 1s. Second shell, that is L, having two different orbitals, 2s and 2p. Same way for M, 3s, 3p and 3d. And for N, 4s, 4p, 4d and 4f. Now, in the first shell, we have two electrons. So the configuration is 1s2. In second shell, we have 8 electron. So the configuration is 2s2 2p6. Same way for M and N, as per the respected number of electrons given, we have set them in the respected orbitals. Now, after filling all the orbitals, if you find it out, the number of s electron in each, it becomes 8. In each shell, we have 2 electrons. It's already highlighted. So the correct answer is option B. Number of type of subshell who has the value of n plus L equal to 7. So for that, look at the arrangement of these orbitals. As per the Aufbau, Pauli and Hund's rule, these orbitals are arranged. And now the condition given in the question as per it, these circled orbitals shows the value 7. For an example, in 4f orbital, n is equal to 4 since it belongs to the fourth shell. And for f orbital, the value of L is equal to the 3. So 4 plus 3 equal to 7, and the correct answer is 4. Here it is asked number of type of subshells. So we have a 4 type of subshells observed in which value of n plus L equal to the 7. The next, that is about the chromium, and in the case of a chromium, the electronic configuration is argon 3d5 4s1. It is an exceptional configuration. Due to exchange energy, it is not follow the Aufbau rule. Now for Cr2 plus, two electrons are removed, one from 4s orbital and the one from 3d orbital. So we have argon 3d4 4s0, and so the arrangement of the electron in 3d orbital is as per the Hund's rule, that is, in each we can explain one electrons, and so that the 4 electrons we have, it remains unpaired. So the correct answer is 4. Hund's rules say that electrons, when entered into the degenerate orbital, they first try to remain unpaired, and after that, the pairing will be started. Now, in this case, the energy value is given, and we have to use the formula of energy and the wavelength, that is E equal to hc by lambda. Put all the value and then take the ratio. So you get the answer, that is option B. Now, next question. The 16-gram oxygen that having actually the 0.5 moles. Remember one thing, 16-gram oxygen means 16-gram O2. So 16 by 32 is equal to the zero point 0.5. Here, zero point 0.5 moles are present only in third number, that is 14-gram nitrogen, and the fourth number 1 gram hydrogen, and these both number 3 and 4 present in the option B. So the correct answer is option B. Now, this question is based on the law of multiple proportion. And here, total 5 compounds are formed between the element X and element Y. Out of two element x and y, the amount of x remains the same and the amount of y is variable. So let it be solved by making the table. We have the five compounds A to E in which the ratio of the element y is 1 is to 2 is to 3 is to 4 is to 5. Now, suppose the amount of the element y which is combined in a multiple of x gram. In that way, we have the element y as a x, 2x and so on. In the question it is given the compound A has 28 parts by weight of x and 16 parts by weight of y. That is 28 gram of x combined with 16 gram of y, and so for that reasons we assume x equal to 28 gram, y equal to 16 gram. Now that y is equal to 16 gram, that's why x equal to 16. In that way, in compound C, we have 48 gram of y combined with 28 gram of x. But in the question it is written that we have only 24 gram of the y, and so that the 24 gram of y combined with half of the x, that is 14 gram of the x, and 14 gram means 14 parts by weight of x. So the correct answer is 14 parts by weight of x. Now, in these questions, the electron drop from n equal to the 5 level. So that if we use the formula number of spectral lines, then directly we get the answer 10. And if you want to draw with the diagram, then also we can see from 5 to the 1, the journey shows total 10 lines developed. So the correct answer is option A. This is based on the stoichiometry. Magnesium react with the oxygen, so it form magnesium oxide. And as per the balanced equation, 2 moles magnesium, that is 48 gram magnesium, reacted with 32 gram of the oxygen. So that we can say like that 48 gram combined with 32 gram. Therefore, 1 gram combined with 32 divided by 48, that is 0.66 gram oxygen. But the given quantity is 0.5 gram oxygen. So oxygen is a limiting reactant. See, this is very important step. First, you should have to find the limiting reactant, and based on it, we can say 0.66 gram oxygen, that is a limiting reactant, combined with 1 gram of that magnesium. That's why the 0.5 gram is combined with 0.75 gram of the magnesium. As per the calculation, it shows, and that's why the correct answer is option C, that oxygen is the limiting reactant along with excess of magnesium, that is 0.25 gram. The number of molecules are given, so it's very simple. From that molecules, we have to convert it into the moles, and the moles we get the 3. Once you get the mole, then the mass is very easy, mole into molar mass. So we get 96 gram, that is option B. It is saying that 50% water by mass present. That means the rest of 50% by sodium carbonate. That's why first we find it out the proportion of Na2CO3 in the given formula, and this is 106 gram, means 106 gram sodium carbonate is combined with 106 gram of the water. Both have the equal proportion of their mass, and that's why the moles of water we get it 5.88, that is nearly to the 6. So the correct answer is 6.